Hello everyone, welcome to this channel. If you're new here, my name is Hasan. Let's begin our fifth part of the video series, and today I will be discussing about the rules of image formation in concave as well as convex mirror. And we'll also analyze the different location of image formation according to the location in which the object is kept in front of the mirror for both concave and convex mirror. And if I can wrap up things quickly, then I'll also touch upon mirror formula. So without any further delay, let's roll the intro. Okay, let's start our study. But before that, let me tell you that if you're enjoying this video series on ray optics, that is studying in style, then please subscribe to this channel because more awesome content are going to come in the future. And if you like these videos and the style of these videos, then please give it a thumbs up because then it will help the YouTube algorithm to suggest these videos to more people out there, okay? And it will also help this channel. Okay, so let's begin our study. So we'll look at a concave mirror, the rules for concave mirror. The first rule is that when rays are parallel to principal axis, then after reflection it passes through focus. So you can see that this is the ray. It is parallel to the principal axis. As you can see, after reflection it passes through focus. And this concept we have seen in our earlier video, like the previous video. So this is our rule 1, simple as that. Now let's look at rule 2. It says that rays passing through focus after reflection becomes parallel to principal axis. So this is just the opposite of rule 1. So this is the ray that is passing through the focus. As you can see, the blue one, after reflection it becomes parallel to the principal axis. So this is simple rule. Now let's move on to our third rule. It says that rays passing through center of curvature after reflection retrace back its path. So this is important. Let me explain you why it retraces back. So whenever a ray is passing through the center of curvature, you know that whenever a line that is passing through the center of curvature falls on the surface of the spherical surface, then what happens? Then that line is actually normal to the sphere. I have told earlier in my previous video that suppose this is the center of curvature, then if you want to draw normal on this surface, then the normal will absolutely pass through center of curvature. Wherever you draw normal, doesn't matter. If you want to draw normal here, then it will pass through the center of curvature. I know the drawing is not perfect, but I hope the concept is clear. So whenever you draw normal on that curved surface, then it will pass through the center of curvature. So as you can see, the rays are passing through the center of curvature and falling on the spherical mirror. So we can say that these rays are actually normal to the curved surface. And we know that whenever a rays falls normal to, as you can see, this is normal. If the rays falls normal to any surface, then after reflection it retraces back, isn't it? So like this, it retraces back because angle of incidence is equal to angle of reflection. Here it will be 0 degree because it is along the normal. I hope the concept is clear. Therefore, whenever rays passes through the center of curvature after reflection, it retraces back its path. Simple as that. Now let's move on. Let me rub this. The fourth rule says that when rays comes and hit a pole, as you can see here, okay, that this is ray that is coming and hitting the pole of the mirror or the spherical mirror, then we see that then the angle made by incident ray with respect to the principal axis. So this is the angle made by the incident ray with respect to the principal axis, that is theta, is equal to the angle made by reflected ray. As you can see, the angle made by reflected ray is also theta with respect to the principal axis. So these two angles will be equal. Now very easy. Why? Because we know that lines passing through the center of curvature is normal. So we can say that this is the green line that I'm drawing is actually normal. If this is normal, then this becomes angle of incidence and this becomes angle of reflection. And we know from the law of reflection that angle of I should be equal to angle of R. So these rules are actually following the law of reflection. I hope this is clear. So I'll repeat again. When rays comes and hit at pole, then the angle made by the incident ray with respect to the principal axis is equal to the angle made by reflected ray with respect to the principal axis. And it's easy if you look into the diagram. I hope the concept is clear. So these are the 4 rules which we will be using in order to find the location of image formed when object is placed in front of the spherical mirror. Now why are these 4 rules important? Because we know, let me write down, in order to obtain image, we require at least 2 rays, isn't it? It is only if we take two rays then we will get the intersection point. So two rays are required. So there are four rules, isn't it? So we will pick any two rules so that we will get two rays and we can find the intersection point. That's why these rules are important. Out of four rules, you can choose any two of them in order to create the image that is formed due to spherical mirror when object is placed in front of it. I hope the concept is clear. Now let's move on to our next concept. Okay, now let's look into the image formed by concave mirror. So there are total 6 number of cases. We will look into each of them one by one. So let's look at the first one, that is object is at infinity. What does infinity means? It is placed at a very high distance. Okay, so one thing you need to understand that whenever something is at infinity, then the rays coming from that will be parallel. Okay, for example, sun is very far away. So actually what happens is the rays that are coming to the earth are actually parallel because the sun is very far away from us. So this is the first concept, that is whenever something is at infinity, the rays coming from that object will be parallel. Okay, so now the first point is done. Now we look into the second point, where will the image formed. Now we know that in order to find the image we need at least two rays. Okay, so these are the two rays, because for intersection we at least require two rays. So the first rays, we know all the rays will be parallel. So according to the rule, we know that whenever rays are parallel to the principal axis, then after reflection what happens? The rays passes through the focus. So both the rays will pass through focus, therefore the intersection point is actually at focus. Therefore we can say that the image will be at focus. So image will be at focus. Done. Number 3, image will be real and inverted. Now let me explain why will be the image real. Very important. The image will be real because the first thing, real images are always formed in front of the mirror. Okay, this has been discussed earlier. And the second point is, it is real because the image is formed due to real intersection. So we are getting the image due to real intersection of rays, therefore the image will be real. Now the image that will be formed will be inverted. Now I cannot show it here how the image is inverted, because look at the fourth point. It says that the image will be highly diminished, almost point. So it's very difficult to show a point object that is inverted. So don't worry, things will get clear. This portion will get clear when I discuss the next case, okay, where the image size will not be point. In that case I can explain. So don't worry, remember one thing, whenever the image is real, you will get inverted image. Now let's look into the final point. So these are the 5 points which are very important in all the cases. You need to remember in this way. Now magnification will be negative. What does magnification actually means? Magnification is nothing but we are just comparing the size of image to the size of object. As you can see, this is the mathematical way of comparing things, that is ratio, height of image by height of object. Now I have already discussed in my earlier video the sign convention in case of optics, and we have said that if this is the mirror and if we move up, then we will take it as positive. If we move down, then we will take it as negative. Now the image formed is inverted, isn't it? If the image formed is inverted, then the height of the image will be downwards like this, therefore it will be negative, and height of object which is upright or erect will be taken as positive because we are going upward. So negative divided by positive will be negative. Therefore we can say that magnification will be negative. Now look at this fourth point. It says that it is highly diminished. So if we take the modulus of magnification, then we will get it will be less than 1. So let me rub this. So magnification will be less than 1. That is the mod of magnification. Okay, because the image is getting smaller. Therefore the mod of magnification will be 1. Why? Because height of image, let me explain it. Height of image is smaller, and height of object is bigger, and we know smaller divided bigger is always less than 1. So a mod of ME will be less than 1. You need to remember all these 5 points for all the cases. So our case 1 is done. Now let's move into our case number 2. In case number 2, we'll see that the object is placed in between infinity, this is infinity, and center of curvature, that is this is C. Okay, and the object has been placed here in between them. So this is our first point. Second point, image formed in between center of curvature and focus. Okay, so we got the image to be in between center of curvature and focus from the ray diagram. So let's understand the ray diagram. This is ray number 1. We require 2 ray, and this is ray number 2. So the first ray is parallel to the principal axis. After reflection, it will pass through focus. Done. The second ray is passing through focus, so after reflection, it will become parallel to principal axis, and the point of intersection is this, which is located in between C and F. Therefore, you got the image in between center of curvature and focus. Simple as that. Now, if we look into the ray diagram, we'll see that the image will be real. So the image is real. Why? Again, because the image is obtained due to real intersection of rays. Simple. Inverted. Look at this. I can explain it now. You can see from the ray diagram that the image formed is inverted. Now, I told that whenever the image is real, we will get inverted image. From the ray diagram, it is clear. So from here, we can see that the image will be inverted. The fourth point is diminished. As you can see in the ray diagram, yes, it is diminished. It is smaller than the object. So this is important. And the magnification is negative. Why negative? Again, since it is inverted, the height of the image will be, we can say it will be negative, and height of the object, since it is erect, it will be positive. So negative divided by positive will be negative. So you can directly say magnification will be negative. Okay, so this is all about case number 2. Another thing I forgot to mention is the modulus of magnification. Again, since the image is diminished, the modulus of magnification will be less than 1. Simple as that. Now let's move on to our third case, when the object is placed at center of curvature. Okay, now what happens? So this is our first point. Object is a center of curvature. Second point, look at the ray diagram. There are two rays. So this is our first ray that is parallel to the principal axis. After reflection, it will go through focus. So it's done. And this is our second ray that is going through focus. Then after reflection, it will become parallel to the principal axis. And we got the intersection point at center of curvature. Therefore, the image formed is at center of curvature. Number 3, the image will be real, because the image formed is due to real intersection of rays. And I told you that whenever the image is real, we will get the image to be inverted. And we can see that the size is same size. So always remember, this is very important. Whenever the object is placed at center of curvature, then the image is also formed at the center of curvature, and therefore the size will be same, obviously. Then magnification will be negative. Why negative? Because inverted. If the image is inverted, then for image we will get a negative sign, and for height of object we will get a positive sign. So negative divided by positive is negative. Therefore we got magnification to be negative. Now modulus of magnification will be 1, because it is of the same size. So this is all about object at center of curvature. I hope things are becoming clear. The story is very simple. Just understand the story. Now number 4th case, object in between center of curvature and focus. So this is our first point. Second point, in order to understand where the image will be formed, look into the ray diagram. So we took two rays. Number 1 is this one, parallel to principal axis. After reflection, it will go through focus. The second ray, we have taken it to be passing through focus. Then after reflection, it will become parallel to principal axis as shown here. Then we see the intersection point is beyond center of curvature. So important, the image will be formed beyond center of curvature. Then number 3rd point, image will be real, obviously, because the image that is obtained is due to real intersection of rays. Okay, the rays are intersecting in real. Whenever the image is real, we will get an inverted image. Simple. Number 4th point, for the first time we got that the image will be magnified. Okay, so always remember, whenever the object crosses center of curvature and move towards the mirror, then we will get magnified image, and the image will be formed behind the center of curvature. I'll explain the story, don't worry. So look into the magnification part. It will be negative. Why? Because inverted again. Whenever there is inverted image, we will get negative magnification, because height of image will be negative because of inversion, and height of object will be positive. So we will ultimately get a negative magnification. Modulus of M. Modulus of M. Now height of image, since height of image is magnified, it will be bigger, divided by smaller. It will be, height of the object will be smaller than the image. Therefore we will ultimately get the value to be greater than 1. So modulus of M will be greater than 1 because of magnification. I hope the concept is clear. Now let's move on to our 5th case, and then I will wrap up the story. Okay, so I am holding the story as of now. Look into this. The object is placed at focus now. So ultimately we are moving closer and closer towards the mirror. The image formed, look into this diagram, it will be clear. The image formed will be at infinity. So the object is at focus. So we have taken two rays. One is parallel to the principal axis. After reflection, it will pass through focus. Another we have taken is a ray that is making an angle theta with the principal axis. It goes and hits the pole. Then after reflection, it will again make angle theta according to our rule number 4. At the beginning of the video, I've explained that. So we got the intersection point way beyond center of curvature, that is at infinity, as you can see here. Okay, so if we look into the characteristic of the image, then we'll see that the image will be real. Why? Because the image that we obtain is due to real intersection of rays, and since it is real, we will be getting an inverted image. And number 4, we can see from the ray diagram, it is highly magnified. Whenever the object is found behind the center of curvature or beyond the center of curvature, it will always be magnified. So it will be highly magnified. And the last point is magnification. It will be negative. Why? Because of inversion. Height of image will be negative and height of object will be positive. So ultimately we'll get a negative magnification. So modulus of m, I won't explain now, it will be greater than 1 because of magnification, because the height of the image is greater than the height of the object. So this is all about the 5 cases. These 5 cases are interlinked. So let's understand the story. Okay, so this is the story. Understand, if this is the mirror, okay, whenever the object was at infinity, then we got the image to be at focus and it was very small. As we start to move towards the mirror, the image starts to move away from the focus, or away from the mirror rather, and it starts gaining height. Okay, it starts gaining height, that is, it is becoming bigger and bigger. When this object reaches center of curvature, then the image also reaches center of curvature and both the height becomes similar. The moment it crosses or moves towards the mirror and it crosses the center of curvature, okay, then we saw that the image moves beyond the center of curvature and it starts to become bigger than the object. This is the story. So this is a link between 1 to 5. The object is moving towards the mirror and the image is moving away from the mirror. See, object cannot become smaller, okay, but the image is going bigger and bigger with each step that is taken in front of the mirror. Okay, so as we are moving forward, the image is going backward and it is becoming bigger and bigger. Once the object moves towards the mirror from the center of curvature, we saw that the image also moved away from the mirror, away from the center of curvature and the object, and for the first time we saw that the image becomes bigger than the object. So this is the wrap up of the 5 cases. Now the 6th case is different from the 5 cases that we have seen. So there is no link between 1 to 5. This is a separate case and a very important one. I will give a star here. Understand this. Whenever the object is between focus and pole, okay. Now in order to understand the image formation, you need to look into this ray diagram. As you can see, the object is between focus and pole. Then we have taken 2 rays. It's very difficult. One ray parallel to the principal axis, this one. Another ray is this one. Okay. So the parallel ray after reflection will pass through focus, as you can see. And this ray will retrace back because it is hitting the mirror normally. Understand this. It is hitting the mirror normally. So it will retrace back and will go through the center of curvature. This is the 4th point that I've explained in the rules of reflection, okay, in the start of the video. Simple as that. Now we saw that the image formed. Now in front of the mirror, both the rays, if you analyze this and this ray, they are diverging rays, so they will never meet. But if we take these 2 rays behind the mirror, we'll see that there is a point where these 2 rays will actually meet. Okay, so the image formation is behind the mirror. So I hope this concept is clear why it is behind the mirror. Now let's look into the 3rd point. Image will be virtual. Why virtual? Because the image is forming behind the mirror, therefore virtual image. I've explained this in a plane mirror. Whenever the image is formed behind the mirror, then it is a virtual image. For example, the image that you see in front of the mirror, plane mirror, every day at home. So those are virtual image. And since this is virtual, it will be erect. If it was real, then it would have been inverted. Okay, now let's look into the 4th point, magnified. So the image is magnified, as you can see from the ray diagram. And the last one, 5th one, magnification will be positive because it is erect. Now the height of the image will be positive because it is erect. And object will also be positive. Therefore positive will be ultimately positive. And the modulus of magnification will be greater than 1. Why? Because the image formed is magnified or greater than the object. So this is the basic concept of the sixth case, and the most important thing that you need to understand here is it is the only case where image is virtual but magnified. Now later in this video you'll see in case of convex mirror that we'll get virtual image always, but every time it will be a diminished image. But in this case, always remember for concave, whenever we're placing the object in between focus and pole, we will get virtual image, but the difference is the image will be magnified, not diminished. I hope the concept is clear. You need to remember these points. The places where I'm tracing is important because they can ask objective from anywhere. Okay, your fundamentals should be as solid as possible. Okay, now let's move on to our next concept. Okay, now let's look at the rules for convex mirror. It is similar to concave mirror only. So let's see. The rule number 1 says that whenever a ray, suppose this one, parallel to principal axis, after reflection it diverges. But actually what happens is if we just trace it backwards, then we'll see that it appears to come from focus. In the earlier case we have learned for concave mirror is that when a ray parallel to principal axis hits the mirror, then it goes towards the focus after reflection. Here also what happens is after reflection it appears to come from focus. Okay, so in the earlier case it was real, in this case it is virtual. I hope the concept is clear. Now let's look into number 2. It says that the rays going towards focus, okay, we can see that the rays are going towards focus, then after reflection the rays becomes parallel to principal axis, as you can see. So it is happening virtually. It is not actually going toward focus. After reflection it becomes parallel to principal axis. So again we can see a virtual things comes into play. Number 3, we can see that it is also similar. Whenever a ray is going towards the center of curvature, then after reflection it retraces back its path. It is similar to that of concave mirror. We have seen that whenever a ray that is passing through the center of curvature, after reflection it retraces back. Why? Because actually this ray that is going to the center of curvature is basically normal to the sphere or the spherical surface, and we know that whenever rays follow the normal, then it reflects back in the same path, because the angle of incidence is equal to angle of reflection is equal to 0 when rays move along normal, isn't it? So simple as that. In plane mirror we have seen that if this is the normal, okay, and if rays follow the normal, then it will retrace back. Same concept is used here. So these are the 3 rules for convex mirror. Mostly we are seeing that everything is happening virtually. Okay, now let's move on to our next concept. Now we will see how image is formed by convex mirror. Very simple. We have taken an object AB here. Okay, now we have taken 2 rays. This is the first ray, okay, that is parallel to principal axis. After reflection it will diverge, and if we trace it back then it will meet the focus, as you can see here. Okay, now this is the second ray. Second ray is moving towards the center of curvature, so the ray is moving in this direction. So after reflection it will retrace back, because as we have seen in our 3rd number rule for convex mirror. So actually what we are seeing is if we retrace back, then we are seeing that these 2 rays are never meeting. That is, it is diverging, so it will never meet. But if we take these 2 rays backward, then we'll see that there is a meeting point and an image is formed at the intersection. So let's see. The first step is done, that is object is placed anywhere in front of the mirror. See, in the concave mirror we got 6 cases, but for convex mirror it is very simple. We will get only 1 case. So object is placed anywhere in front of the mirror, doesn't matter, it will behave in the same way. Second point, image formed in between focus and pole behind the mirror. Very important. So we'll see that the image will be formed always between the focus and the pole, and it will be always behind the mirror. Now we know that when images are formed behind the mirror, then that image is known as virtual image. So we can see that the image formed is virtual, and from the ray diagram we can see that the image is erect. So let me highlight this part. So the image formed is erect and it is virtual. In the earlier cases we saw that anytime real image was formed, we got inverted image. So we can see now that whenever image is virtual, we will get an erect image. So this is done. Now let's look into our fourth point, that is image is diminished, that is the size will become small, as you can see from the ray diagram. In the earlier case, I have said that in case number 6 for concave mirror, I said that whenever virtual image was formed, that is this was the case, this was the concave mirror, and if this was focus and this is pole, and we place the object somewhere here between focus and pole, we got a virtual image that was magnified, and that is the only case where we can see this kind of behavior. But here what we will see that even though we are getting a virtual and erect image, we will get a diminished image. Okay, now let's look into magnification. Now we know magnification. What does magnification means? It is just comparing the height of image to the height of object. Now height of image, as we can see, erect image is erect, therefore the sign convention will be positive, and height of object, since it is also erect, therefore it will be positive, so positive divided by positive will be positive, therefore the magnification will be positive in case of convex mirror always. Okay, now the most important point here is if we move the object away from the mirror, this can be asked in objective, like if we move an object away from the mirror in case of convex mirror, then the image will move towards the focus, very important, and will go on becoming smaller and smaller. So let's look into our diagram, it will be clear if you look into the ray diagram. If we move this object backwards, okay, further away from the mirror, we will see that this image will move towards the focus and it will become smaller and smaller. Now a similar thing was happening in case of concave mirror. Look at this. If this is the focus and this is the center of curvature, if we keep on moving the object backward, what we saw was that the image that was inverted starts moving towards the focus, and it was becoming smaller and smaller, and ultimately when it reached infinity, okay, at infinity, the image got so small that it turned into point object. Similarly, here you can see that whenever this object is moving away from the mirror, we can see that the object is moving towards the focus and it is becoming smaller and smaller. So the story is same. So this is all for this image formed by convex mirror. I hope the concept is clear. Okay, now let's look into this concept of mirror formula, and this will be the last part of the video. Okay, so let's see what is mirror formula and what does it do. Now mirror formula is the formula that gives us a relationship between focal length, object distance and image distance. Okay, the focal length is the length from the focus to the pole, object distance is the distance of the object in front of the mirror, and the measurement is done from the pole, and the image distance is the distance at which the image is formed and the distance is measured from the pole. Okay, and the relationship says that 1 by f is equal to 1 by v plus 1 by u. So this is the relationship between the three terms. Okay, now let's prove it. How to prove this thing, like 1 by f is equal to 1 by v plus 1 by u. So let's see. Now if you look into the proof of NCERT, then it's a bit complex and understanding that thing is very difficult. So there's always an easy way to explain things, and I feel like this is the easiest way of proving this concept. Okay, let's dive into that. Now if you look into this ray diagram, okay, I have colored two triangles in green and two triangles in yellow. So first of all, we will look into the triangle that is colored in green, that is triangle ABO and triangle OMP. And we said that these triangles are similar. How? We know that similar triangles are triangles in which both the triangles have same angles. Okay, all the three angles are same for both the triangle. And we have proved that. That is angle AOB is equal to MOP, that is vertically opposite. Angle BAO is equal to angle MPO, 90 degree. If two angles of both the triangles are equal, then the third angle has to be equal. Okay, so angle ABO is equal to angle PMO. This is how we prove that both the green triangles are similar. And now we'll be using the property of similar triangle. If you don't know the property of similar triangle, then you can Google it and you can easily find out. I hope you know. Okay, this is very, very basic. So we can say from the property of similar triangle that AB divided by PM is equal to AO divided by OP. Okay, just pause the video if you're having problem and look into the ray diagram and it will be clear. Now, from this relationship, we can say if we put the values, AB is nothing but height of the object. So AB is height of the object. And PM is height of the image. So PM, this is nothing but height of the image. You can look into the diagram, okay, because PM is similar to A dash B dash is equal to AO. If you look into the diagram again, you'll see AO is nothing but U minus F. Let me draw it. So this is u, that is the object distance from the pole, and this is image distance from the pole, that is v. Okay, now this is clear. So what we did is AO is equal to u minus f. Now it is clear, I hope. So AO is nothing but u minus f, and OP is just the focal length. Simple as that. Now similarly, if you look into our second triangle of the second case, that is the triangles that are colored in yellow color, that is triangle A-B-O and triangle OPN, we can say those two triangles are similar, and we can prove it in the similar way we have proved these. Okay, so I'm not proving that. You can do it on your own. So we can directly apply the property of similar triangles here and can say that A-B- divided by NP is equal to A-O divided by OP. Now A-B- is nothing but height of the image. So A-B- is height of the image, and NP is, that is this height, is height of the object. Now A-O is V minus F. You can look into the diagram, it will be clear. And OP is simply the focal length. Now if you look into this equation 1 and equation 2, one thing we can do is we can write that HO by HI is equal to F divided by V minus F. Okay, so that it will be easier to compare with equation 1. Let this be equation 2. I've just flipped the equation 2. Okay, now if you look into equation 1 and equation 2, both are having HO by HI. So if we compare both the value of HO and HI, we can say that U minus F divided by F is equal to F divided by V minus F. Simple as that. This is simple mathematics. Okay, I have nothing to explain. Now what you need to do is just simplify the equation. Okay, just cross multiply and find out the equation. Like if you cross multiply, you'll get F square is equal to U minus F multiplied by V minus F, and if you solve that, you'll get UV is equal to UF plus VF. Now if we divide both sides with UVF, we will get 1 by F is equal to 1 by V plus 1 by U. Okay, so this is basically the mirror formula that we need to derive. Okay, so this is all about mirror formula derivation. Now one thing you need to remember, that the value of F, that is the focal length, and the image distance V and the object distance U, when we will be solving numericals, we will put the values with their respective sign. Just don't put the magnitude and solve the equation. Okay, you need to put the values according to the sign, and I have already discussed the sign convention in my previous video. So if you haven't checked my previous video, then please check that video, the concept of sign convention there, and it will be easy. This thing will be clear when I'll be solving some MCQs related to NEET, and then it will be easy. A piece of cake. Okay, these are very simple, and most of the time questions are asked from this part. Okay, so you need to focus this part. So this is all for this video. Don't worry, this thing will be much clearer when I discuss some numericals in my next video. So this is all for this video. If you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.